So we first start with 0.6 moles because that's what the problem gives us. We write that out here. We put multiply, and then what's this right here that goes on the bar? What do we call that? Again, what do we call this right here? That's our conversion factor. We call it a conversion factor because we're converting from one thing to another. In this case, which I can already see I did something wrong. Nobody stopped me. What am I missing?
The gas.
Good, N2. So 0.6 moles of N2. Now we put our conversion factor. And what are we wanting to convert it to? What is the question asking? So we are looking for moles of ammonia, NH3. So now this is just like the problems we did a few weeks ago. We take our number, our unit that we're wanting, and where do we put it?
On the bottom?
The unit that we want
On top.
goes on top. Okay, and then what goes on bottom? The given, the unit that we're given, moles of N2. Now, where do we get the numbers out front? Where do we get the numbers? The coefficients. What number is in front of the NH3? A 2, so we put a 2 here. What number is in front of the N2? 1. Now we can just do the math. What is 0.6 divided by 1? 0.6 divided by 1? 0.6. What's 0.6 times 2? 1.2. That's our final answer, 1.2 moles of NH3. Alright, for this problem right here, the first thing we need to do is balance the equation. Okay, we cannot solve any mole problems until we've balanced the equation. So I'm going to give you and your partner 1 minute to try to balance the equation. Go. What are the coefficients you get? Good. We get 4, 3, 2. So 4 aluminums react with 3 molecules of oxygen gas to form 2 aluminum Al2O3. Okay, so that's our balance equation. Part A. Part A says write the 3 mole ratios that can be derived from this equation. So the first mole ratio that we're going to do is going to compare those two together. Okay, so we're comparing these two right here. 4Al and 3O2. So we simply write it 4 moles of Al. And what are we comparing it to? 3 moles of O2. That's all it's asking for. Write the 3 mole ratios that can be derived from this equation. That's the first one. Okay, and how many total are we going to have here? 3. So for every one that asks for, we can just go ahead and write down our conversion line. Now the second one that we're going to compare is this one and this one. So what goes on top? And what goes on bottom? As I said, we're comparing this one and this one.
2.
So which one goes on bottom?
2.
2 moles of Al2O3. Oh, so I wrote it on the wrong line. Either one's fine. Doesn't matter. Nope, you can go back, and because these are conversion factors, you could actually flip those. Remember we said they can be flipped. Doesn't matter as long as you have that conversion factor. Now the third one that I skipped, the third one, we're going to compare this one and this one. So what goes on top? 3 moles of what? And what goes on bottom? And those are our 3 conversion factors. So when you're doing the conversion factors, you have to make sure that you're comparing each substance to the other one in that equation. So we first compared this one and this one. Then we compared this one and this one. And then the last one was comparing this one and this one. So we got 3 different conversion factors out of that. Now for part B. It says how many moles of aluminum are needed to form 4 moles of Al2O3. What are we starting with in this problem? 4 moles of Al2O3. So we start 4 moles of Al2O3, set up our conversion factor, and what substance are we wanting to convert it to? Not just aluminum, but what? Moles of aluminum. So this is going to be important because we're going to start getting to other stuff other than moles in the next couple weeks. So we're converting it to moles of aluminum. Now we can start plugging in our units. What unit goes on bottom? What unit goes on bottom? Al2O3. What unit goes on top? Moles of Al. Good. Now that we have that, where do we get our numbers from? The coefficients. So what coefficient is front of Al?
4.
A 4. What coefficient is front of Al2O3?
2.
Good. So we put a 4 here and a 2 here. Now we do the math. What's 4 times 4?
16.
16. What's 16 divided by 2?
8.
So our answer is 8 moles of aluminum. So the way we say this is that if we have 4 moles of aluminum oxide, Al2O3, so if we have 4 moles of this, it will need 8 moles of aluminum to make it. So in order to make 4 moles of Al2O3, it needs 8 moles of aluminum. Okay, does anybody still need this? Okay, so part C right here. What number does the problem give us? 16 moles of Al. So we start with 16 moles of aluminum. And what is the problem asking for? Good. Moles of oxygen. So we set up our conversion factor. And our answer is going to be moles of oxygen, which oxygen gas is O2. So now we could write moles of O2 on top, moles of Al on bottom, and what coefficients going for each one of these? What's the coefficient for O2?
3.
And coefficient for Al? Good. So the first thing I would do is go 16 divided by 4. What's 16 divided by 4?
4.
4. So then we have 4 on top. 4 times 3 is?
12.
12. Good. So the way we read this equation is that if you are going to react completely 16 moles of aluminum, it will require 12 moles of oxygen because those are both reactants.